Welcome to week 5, and this week we're going to talk about the advanced inheritance. So in this week's lab, you're going to see a lot of information on inheritance and so forth. So kind of getting into this, the objectives this week is to create and use abstract classes, the use of dynamic method binding, create arrays and subclass objects, the use of object class and its methods, inheritance to achieve good software design, and we'll talk about that. Create and use interfaces and packages. Abstract classes cannot create in concrete objects. They can inherit, usually has one or more empty abstract methods. So when declaring an abstract class, use the keyword abstract, obviously. You provide a superclass from other objects that can inherit it. So for example, you type in public abstract class and then whatever class is animal, vehicle, football, or sports, etc. So what does it not have? The abstract does not have a body. It does not have curly braces, and it doesn't have method statements. And when we do the lab, when you go over the lab this week, you'll see when I write an abstract, I'll create an abstract for you and show you how to do it, and you'll see how I go through it, and then it'll make more sense. Creating an abstract method, use the keyword abstract. We said that. The header must include a method type, name, and parameters. Obviously, include a semicolon. So kind of like here we have public abstract void speak. So you can have public abstract void, maybe something specific, receptions, passes, etc. Subclass of an abstract class inherits the abstract method from its parent. Must provide an implementation for the inherited method, or B, abstract itself. Code a subclass method is to override an empty superclass method. So here's an example. We have the app emulator, and then we have a machine, which is one of our classes that we're going to be interfacing with, or abstracting with. We have getters and setters, and then an abstract in there. We have another class called camera. Camera has specific functions it has to do. It's going to start, do stuff, and shut down. Same thing with the car. But they're going to have different analogies. Camera is going to maybe take a shot, start the camera, shut it down. Vehicle, start the ignition, shut down the vehicle, and do something. And then here's the machine, which is the class that implements. These guys implement from the machine. And then the app emulator calls this and calls all this information. Now, it seems a little confusing, but we'll actually do this in class, well, in the lab. I'll write some code that does this and creates the abstract. It's like an inheritance. Some classes talk to the main class. Main class has an abstract class, but it can't instantiate a abstract class directly. Open up Eclipse. Let's code. Well, I apologize because this is more for the in-person class. In person, we actually kind of coded this in person. This class I've had in person, I have online. Let's skip that. But if you follow the lab, then it's the same thing. Right here, I won't go through this, but it kind of gives you an example of some of the methods. Finalize, class, hashCode, notify, etc. Moving down, toString method converts an object into a string. Contains information about an object, output, class name, @sign, hashCode. Write an overload version of a toString. So display sum of all data values from an object. It can be very useful in debugging a program. So display the toString value and examine its contents. So in this example here, we have public class test, which is our main thing. We have our main section. We have bank account. We're setting up a new instance of that class, and then we're calling and saying system out print line myaccount.toString. Pretty simple stuff. Create an example of a board. Once again, we're not in class, so we're not doing that. Equals method takes a single argument, the same type of invoking an object, returns a Boolean value, indicates whether objects are equal. Consider two objects of the same class to be equal. So if we did if some object dot equals some other object of the same type, system out. So as you see here, we do dot equals instead of equals. To consider objects to be equal based on contents, you must write your own equals method. So here's an example of one. We have a public app static void main or person instance. Column 5. Let's see. We have equals there. That's not what I'm looking for. Yeah, that's fine. Right here we have system out println person1 dot equals person2. So you see where we're using equals at. Object method hashCode returns an integer representing the hashCode. When you override an equals method, you should override a hashCode method as well. So what is a hashCode? Object method hashCode calculated number is basically a way to store information. So whenever you override the equals method, you should override the hashCode method. Let's see here. We have our public information, public bank account. We're overriding the string to string. We want to do our own thing. Then we have our Boolean down here. Yes, you can create a powerful program with more of it easily with components as is, or with slight modification. You can make programming large, the system more manageable. Advantages of extendable superclasses: same development time, much code is already written, saving testing time, and programmers understand how the superclass works. Creating and using interfaces. So multiple inheritance. Inherit from Java from one class. It's prohibited in Java. Variables and methods in the parent class might have identical names. This will create conflicts. So which class should super prefer when the child class has multiple parents? Interface. It's an alternative to multiple inheritance. Looks like a class except of all its methods are implicitly, man, today's a bad day. Public and abstract, and all the data items are public, abstract, and final. So, or basically implicity. A description of what a class does. Declares methods headers. Interface does not have a method implementation. All methods in the interface are public and abstract, and any field that is declared as public, final, or static. Here's an example of an interface. So I used Apple because Apple has multiple things that they interface with. So you have computers, operating systems such as OS X. You have your iPhone, so it could be iOS 8, 9, 10. Same thing with iPad and iWatch. So Apple is the main emulator, but all these things right here interface with Apple, the iPad, iWatch, etc. That's an example of interface. So you have this main area where you have your code at, and it has these little other output areas that do something specific, and they're interfacing with one main area where they could all be co-joined together. And we'll write some interface in our code. So in this example here, we have public interface Apple. We have abstract void purchase. And then in our iPhone one, we have void charge. And computers, we just have a public class computers. Our interface for OS as an abstract. And then we say public class Apple extends computers, because we're extending the computer class and we're implementing the iPhone OS. We're putting information there. So this interface allows you to form multiple relationships between different models. You can extend any number of interfaces. Create an interface. You do public interface worker. Now in Eclipse, I'll show you two different ways to write interface. You can easily create a class and just change the class to interface, or you can right click and do new interface. So you have two different options there. Implement an interface. Use the keyword implements. You're not going to use extends. You're going to use implements. Requires a subclass to be implemented from its own version to each method. Use the interface name in the class header. Let's see, abstract classes versus interfaces. I kind of talk about this a little bit. in our video of our actual lab work. So once again, you can instantiate concrete objects of either. Abstract classes can contain non-abstract methods, provide data or methods that subclasses can inherit, and can include methods that contain the actual behavior of the object performs. Abstract classes versus interfaces. Interfaces can contain data fields. They can contain constraints. Here's an example of a public interface. We have public interface, pizza constants, and then you have these, as you mentioned here, static final and small diameter, large diameter, etc. All like we mentioned. What's a package? It's the name of a collection of classes, easily imports related classes into new programs, encourages other programmers to use software, etc. Create classes for others to use, protect your work, include a package statement at the beginning of a class file. We've already been doing this. Compile a file to place into package. I'm kind of skipping this because we're already doing this, and we're not going to have you do that. What's jar? You may have heard jar file. It's a Java archive. It's a package or class library. It's delivered to users as a jar file. It compresses and stores data, and it's based on a zip format. So we talked about creating, we kind of went through this really quick, 11 minutes. We talked about creating abstract classes, interfaces, things that you don't want to do. But summary, abstract class, we talked about dynamic method binding, interface packages, mainly interface, and abstract classes we talked about. And when you watch a lab video, it'll make a lot more sense. And we talked about the equals as well. So hopefully you have a good week. Best of luck week 5. And I'll talk to you soon. Thanks for listening.